Our next speaker is Katie VinZant, and I'm so thrilled that she's here in person to speak with us today. She has been a botanist for the Angeles National Forest and now is on the on the Coronado National Forest. Thank you for coming back. Today she's going to talk about, let me tell you, implications for chaparral restoration from exotic root-rotting Phytophthora. Thanks, Katie. Yes, and there's also this. Ooh, fancy. Let me make sure it's on. I don't know why the title's missing. Where is it? Oh no. There's more stuff missing?
Yeah. Uh-oh. We should have done a dry run.
Do you have your broomstick?
Yeah. It looks like most of my talk is the words are missing. Is this on 10?
Yes. Let's try from your broomstick.
Hold on.
Quickly. Sorry.
Technical difficulties.
Do you want to try to introduce your topic at least?
Yeah. Okay. So I hope everyone is ready to become even more depressed because this topic is not exactly like heartwarming. So I'm going to talk to you guys about Phytophthora. And Phytophthora, for those that don't know, is, and we have Susan Frankel here, who's a plant pathologist, who's going to probably say, you've got this all wrong after I explain it. But it's a combination of a fungus and an algae, and it's basically this little sucker that can destroy the roots of plants. You guys might know it as something called sudden oak death, or something that caused the potato famine in Ireland. This is the same little bugger that we're looking at here, that is causing impacts to.
It's not. I don't think it's going to return. I'm sorry.
Okay. It's all right. We'll see if I can do this. So let's see if I can at least show the pictures. So this is one of our restoration sites on the Angeles. We have a bunch of container plants. This is a little picture of Phytophthora. Okay, so why do we care about this thing? Other than sudden oak death, we started to realize, well, how are we spreading this around? And the answer came in the form of, we're spreading it around through our nursery plants, through our container plants, which we think we're doing this great thing. We're putting out all these container plants for restoration, but lo and behold, maybe they're harboring something that is, could be a potential damaging factor. So when I caught wind of Phytophthora, we started thinking about, well, on the Angeles, we have roughly 40 different restoration sites covering over around 100 acres that we were planning to do restoration on, putting out container plants, roughly 150,000 container plants at 4 different nurseries. So it's like, maybe we need to start testing these things. Maybe we need to figure out what's going on with these container plants. And we already had some of these sites were already planted with their first or even second phase of container plants. So what it's supposed to say here is, which grouping has Phytophthora? Can you tell just by looking at container plants, what may be diseased and what is not? And the answer that I can tell you is that they both are. But you can tell that by looking at the bottom one, like that looks relatively healthy, right? And that set actually has at least, we cultured at least twice as many Phytophthora species from that set as from the above set, which looks much poorer. So bottom take-home message is that you can't tell by just looking at container plants whether they have Phytophthora or not. So this is the fun method that we use to test for Phytophthora. It's called pair effluent baiting, which sounds crazy. It's science at its coolest, I think. So we take container plants, we have them elevated, we have a catchment system, a tarp, and then this little ghetto igloo cooler with a pear floating in it. And we're running that effluent. We're watering the container plants every 15 minutes for an hour and a half. And we're trying to catch Phytophthora and like their little spores and see, if the plants are harboring Phytophthora. So we run that test and then we let the pears sit. They sit in that effluent for about 3 to 5 days. And then we read the pears. We pull them out. It's like magic, and we wait for lesions to appear. We hope that they don't, because the lesions mean that they're infected with Phytophthora. So what this side is supposed to say is that this is relatively good. This is decent. We have some pears here with some lesions, but some of the pears are looking all right. This, on the other hand, is not good. So this is Phytophthora lesions covering these pairs. I think one of the pairs had something like 4 different species of Phytophthora. And one thing I realized I forgot to mention is we know of around 100 species of Phytophthora. There's projected to be roughly 500, at least 500 other species. So the next step is to culture those species. So we take the lesions and we culture them, put them on agar, and then they read like the genetic testing. I'm not a geneticist, so I'm going to butcher this, but they do a lot of sequencing to figure out what those species are. So we ran all these tests, and we've of the 25 native plant species that we tested, we included 6 rare species that were being grown for these sites. We found 8 different Phytophthora species growing there. Some of those were hybrid species, which apparently is really not good because a lot of that means that things are mixing, and that's never probably a good thing. So on 18 different host species is what we found, and 1 was found on the rare manzanita that we were growing for outplanting. Okay, so this is supposed to say, this is really embarrassing. Half the talk is missing, but oh well. So of the 4 different nurseries, these are all the different Phytophthora species that we found, and then the host species that they were found on. So there's a wide variety. I think I said 25 different plant species. So the take-home message here is that it's not, a lot of times they don't seem to be site or species specific. Some of these Phytophthora species can grow on multiple different species. Okay, so we found Phytophthora growing in nurseries. We knew that they were, that was going to be an issue. We were hoping it wasn't going to be for our particular plants, but that wasn't the case. So the next step in our thought process, well, is this surviving out in the field? Is this something that we need to be concerned about? It's hot and dry in Southern California. Do we need to worry? So we went out to our restoration sites. I think we had about 30 different sites that were already planted, and we went out and started taking samples of those sites. And so the method for testing for sites that are already tested is you just dig up some of the soil, you get as much root matter as you can, you stick that in a bag, and then you dunk your pear in there with some water, and you're trying to breed that Phytophthora again. So bad news, we found Phytophthora surviving at most of the sites that we tested. 6 different species, and a lot of these species were matching the nursery that we tested, like the host nursery that we had obtained the plants from. So clearly seemed to be moving from the nurseries into the wildland and surviving. So these plants, some of the sites that we tested were planted 6 months prior to testing. Some of them were planted 8 years prior to testing. The 8-year site, we found Phytophthora growing there. So it's a correlation, of course, but it seems to be that Phytophthora is surviving pretty well for multiple years in the field. One thing that we did not notice is any obvious impacts to native species surrounding those restoration sites. We didn't see any die-off around them. That's something that we're still definitely monitoring. We'll see. Okay, so this is supposed to say, so we found it in the nurseries, we found it in the restoration sites. We have 150,000 container plants being grown, working with multiple utilities. What are we going to do with all of these plants at this point? And the decision was made from the forest supervisor level that we were not going to accept any of those plants, with the exception of a few species that came out clear and were being grown in isolated areas of the nurseries. We accepted those. But you can imagine the economic impacts that had to decline all of those plants. So, at the end of the day, we figured that the risk was not worth the gain to put those plants out. One thing that has been done in Northern California is trying to solarize sites that have had outplanted Phytophthora, and that, from what I understand, has not been very successful. So knowing that, we figured that was a lesson learned, that we were not going to put the plants out. So, what came of all of this other than rejecting all of these plants? So I worked on a briefing paper for the Forest Service that is, we hope, went out to a lot of the different forests explaining, hey, this is a problem, this is what we're finding, this is how to maybe you should start doing testing too, and working with Phytophthora as a native working group, looking at their BMPs or best management practices, on working like how to work with nurseries, what to put in contract specs so that we're not getting plants that have Phytophthora. Just starting to have that dialogue with the nurseries, I think, is key. So what are we doing on the ground? We're doing additional testing of nurseries. We now mandate that testing has to be done prior to plants going out on the Angeles, and we're moving more towards using just seeding methods of restoration rather than container plants until we can get a handle on this problem. So I just wanted these arrows to show some things to look for in nurseries. This is very detailed, but I'll run through some key points to look for. One is to make sure that plants, the best thing is to get them off the ground. If they're sitting on the ground, it's a direct vector for spreading Phytophthora. This nursery happened to have the highest rate of Phytophthora in most species that we found. And I think a lot of that may be due because the plants are on the ground. When you water, all that, everything can move around that way. Not sterilizing your pots, that's another good way to spread Phytophthora. Not having solarized soil piles. You can see the soil piles here in the back. That's just sitting out next to where they drive on this road. So there's just a lot of vectors going on to spread Phytophthora. And this is supposed to be, thank you.